Hello everyone and welcome to day 3, which is on chords and arcs. First, let's start off with a couple theorems. So we have the Chord Arc Theorem that says that two minor arcs are congruent if their chords are congruent. Next, we have the perpendicular arc of a circle theorem, which says that if a diameter is perpendicular to a chord, then the diameter bisects the chord. So it cuts the chord in half. And we can kind of see that demonstrated in this picture right here. We have the diameter that goes through the circle, and it cuts this chord into two equal parts. Then we have the converse of that, which is just the opposite, which says that if a chord is perpendicular to another chord that goes through the center, then that chord is the diameter. And then we have the equidistant chord theorem, which says that two chords are congruent if they are equidistant from the center. Equidistant means that they're the same length from the center, so you can kind of see this in this picture right here, with two equal distances from the center to the middle of my chord. So I can say that those chords are congruent. Okay, let's do a couple examples. For these first three, we're just trying to find the measure of the arc MN, which is this arc right here on all of them. MN, MN, MN. On number 1, we know that this chord and this chord are congruent. It marks them congruent with those two lines. That means that their arcs are also congruent. So y is equal to 142, just like this other one. Now, since we know that there are 360 degrees in a circle, that's how many degrees I have total. So I'm going to take away the 142 that we have for that one arc that we just found, and the 142 for the arc that it gave me. And when I subtract both of those, I get 76 degrees. So my arc NM is 76 degrees. For number 2, I know that this arc is 132, and this arc is also congruent to this arc, which is also 132 because they're congruent. I also know that these other two arcs are congruent. It marks them congruent. So I have 360 degrees in a circle. I have two arcs that are 132. When I subtract those, I get 96. Now, since my other two arcs have to be congruent, I can divide this by 2. So 96 divided by 2. And that'll give me the measure of one of them because they're the same. When I divide that by 2, I get 48. So this is 48, and MN is 48. And last one, number 3. I know that this diameter cuts this chord into two equal parts because it's perpendicular. So using the perpendicular bisector chord theorem, I know that those two parts are congruent. So since those two parts are congruent, their degrees are congruent. So this one is also 74 degrees, which makes these two arcs that we don't know also the same. So I'm going to do 360 minus 74 minus 74. So minusing what we already know. And I get 212. Now since my other two arcs are the same, I'm going to divide that by 2. And I get 106. So both of my arcs are 106. And for number 4 through 6, I'm trying to find XY, which is the line segment XY. So for number 4, I am told that ZY, this line segment here, is 3. Now I know that this chord is congruent to this chord because those angles are congruent. So this chord and this chord are the same, which means that this chord is also 3, which means XY is 3. For number 5, I am told that ZY, this whole section, is 6, which means that these two parts that are the same are both 3 to make it 6. So 3 and 3. I'm also told that XW, this portion, is 4. Now, since these are right triangles, and I need to find XY, which is right here. Since those are triangles, I'm going to use the fact that this is a right triangle to solve for XY using the Pythagorean theorem. So 3 squared plus 4 squared equals c squared, or this will be c. And then I get 9 plus 16 equals c squared. So that's 25 equals c squared. Square root both sides, and you end up with c is equal to 5. So xy is 5. And I'm going to skip number 6, and you can do it if you'd like. I'm going to move on to number 7 and 8. So number 7, I'm told that this chord, or these circles, are congruent, and I'm also told that this arc is the same as this arc, which means that these line segments are the same. So I'm just going to set these two chords equal to each other. So 2x plus 1 is equal to 3x minus 7. I'm going to subtract 2x from both sides. And I'm going to get 1 is equal to 1x minus 7. Add 7. And I get 8 is equal to x, or 1x. So that's not what I'm asked to find. I'm asked to find PQ. Well, PQ is this line right here. So now that I have x, I can just plug that back into PQ. And solve. 3 times 8 is 24, minus 7. And 24 minus 7 is 17. And last question is number 8. I'm told PQ, which is this part, is 3x minus 4. I'm also told that RS, which is this part, is equal to 14. And I need to find x. So, based on one of our theorems, I'm told that two chords are congruent if they are equidistant from the center, which in this case they are both equidistant from the center. It's both 8 from the center. So those two chords are equal to each other, so 3x minus 4 is equal to 14. So 3x is equal to 18 when I add 4 to both sides. Divide by 3, and I get x is equal to 6. And I'm just told to find x, so I'm done. And that's it for day 3, so I'll see you guys all back for day 4. Bye!